Okay, we're going to do question 12.6 now. So in this question, it's asking you to consider an example of stacker-batch model that was discussed in the textbook. So firms basically choosing quantities to maximize their profit, with firm A moving first and firm B moving second. Alright, so as in the text, the market demand is given by Q equal to 120 minus P, and the production doesn't cost anything. Right? So part A of the question telling you that if B's best response function is given by QB equal to 120 minus QA, everything divided by 2, and the question asking you to substitute the best response function for firm B into the profit for firm A, to find the expression for the profit for firm A in terms of QA. Okay, so we're going to do that first. Alright, so we have the profit for firm A is going to be total revenue minus total cost. Okay, I'm just going to derive the profit function again. Now you can always looking back at the textbook, and the equation 12.3 over here is basically giving you the profit function for firm A. Okay, so we know that profit for firm A is going to be equal to total revenue for firm A minus total cost for firm A. Okay, now in this case we know that it's going to be easy because the cost is 0. Okay, so we do not have any total cost, so the only thing we need to worry about is total revenue, which is going to be equal to the price in the market times the quantity produced by firm A, which is QA. Okay, now the demand function is given by Q equal to 120 minus P, so therefore P is going to be equal to 120 minus Q. Right? Remember, this big Q over here is the total quantity demanded in the market, which is the total quantity supplied by firm 1 and firm 2, okay, by firm A and firm B together. Alright, and we multiply by QA. Okay, so over here what I got is 120 minus QA plus QB. Okay, just like I said, Q is basically equal to QA plus QB, and everything multiplied by QA, and that is going to give you 120 QA, okay, minus QA square. Alright, how about I substitute QB into here first. Okay, so this is basically the profit function for firm A, and now what I do is I substitute QB equal to 120 minus QA divided by 2, okay, into the profit function for firm A. Okay, so I'm going to get the profit function is going to be 120 minus QA minus QB, and I know that QB is just equal to this. Okay, so QB equal to 120 minus QA divided by 2, and everything now multiplied by QA. Alright, so if I simplify this, I'm going to get 120 minus QA minus 120 minus QA a half. That is going to give me 120 minus QA a half. Okay, so divide by 2, and everything multiplied by QA. Okay, so that is, if I take a 120 divided by 2, I'm going to get 60, and this is going to give me half of QA. Everything times QA, so that is going to be 60 QA minus half of QA squared. Alright, so that is the profit function for firm A. Now I'm going to do the second part of part A. So it's basically asking you to substitute the best response function for firm B into firm B's profit function to compute firm B's profit as a function of QA. Okay, so we're going to do that. Alright, so over here for firm B, what we have is the profit for firm B, again just equal to total revenue for firm B minus total cost for firm B, and again total cost is just going to be equal to 0, so therefore it's just going to be equal to the price times the quantity produced by firm B, okay, which is QB. Again, the price is just going to be 120 minus the big Q times QB, and again big Q over here is just QA plus QB. Okay, so 120 minus QA plus QB, and everything multiplied by QB. Alright, so if now I substitute QB equal to 120 minus QA divided by 2 into the profit function for firm B, which is pi B, I'm going to get pi B equal to 120 minus QA minus QB, okay, and QB in this case is just 120 minus QA divided by 2, so that's just same as before, multiplied by QB, and again remember QB is 120 minus QA divided by 2. Okay, so if now I simplify this, I'm going to get 120 minus QA minus 120 minus QA a half. So that is going to give me 120 minus QA a half. Okay, and multiply by 120 minus QA a half again. So that is going to give me 120 minus QA a half square. Okay, now 120 on 2 is just 60, and 1 on 2 is just a half of QA, and everything square. Alright, so that is the profit function for firm B in terms of QA. And the last part asking you now write the expression for A's profit if firm B producing nothing, 0, as a function of QA, okay, and labeled pi M. Okay, over here, so if firm B produce nothing, okay, 0, then QB is going to be equal to 0. Okay, so if we substitute QB equal to 0 into the profit function for firm A that we found earlier, okay, we are going to get profit pi M, okay, which is the profit for monopoly. So in this case, firm A will become a monopoly because firm A is the only firm who is producing in the market. Okay, so if we substitute QB equal to 0 back into firm A's profit function, so over here, okay, so this is profit function for firm A, pi A equal to 120, okay, minus QA minus QB, and everything multiplied by QA. Okay, and now if QB equal to 0, that is going to become 120 minus QA times QA, and that is the profit function for firm A if firm A is a monopoly. Okay. Alright, so part B asking you to use the formula that you derive in part A to fill in the following table. Okay, so in the table we're going to have quantity produced by firm A, and the question asking you to find the profit by firm A, profit by firm B, and the profit by firm A if firm A is the only one who producing in the market, which is the profit monopoly. Okay. Now, if firm A producing 0 unit of output, 20 unit of output, 40 unit of output, 60, 80, 100, and 120. Okay, it's pretty straightforward. We already have the formula that we found earlier. So we just have to substitute it into here. Okay, so I rewrite whatever I got earlier just to make it easier. Over here, so I'll move it a little bit. Okay, so for firm A, the profit for firm A I found earlier is going to be 60, 60 QA minus half of QA squared. Okay. Now the profit for firm B I found earlier is equal to 60 minus half of QA everything squared. Okay, and the profit for firm A being a monopoly is equal to 120 minus QA times QA. Okay, so I got the formula for achieve the profit. Now I just have to substitute the value QA in. So QA equal to 0, the profit is going to be equal to 0. The profit over here for firm B is going to be 60, and the profit for the monopoly again is just going to be 0. Now if quantity equal to 20 over here, 60 times 20 is 1200 minus, so that is going to be 1000. Okay, now if quantity QA equal to 20, it's going to be 2500. Okay, and over here the monopoly profit, if QA equal to 20, 120 minus 20 is 100 times 20, so that is going to be 2000 for the monopoly. Okay. Alright, so if quantity equal to 40, it's going to be 2400 minus 800, so that is going to become 1600, right? And over here QA equal to 40, that's become 20, and that is going to give me 1600 as well. So the two firms are exactly the same, and the profit for firm A being a monopoly is going to be 40 times 80, so that is going to be 3200. Now quantity equal to 60, that is going to be 3600 times, so that is going to be 1800. Okay, over here 60 is going to be 900, and over here if the firm producing 60, it is going to be 3600 for the firm. Quantity equal to 80, that is going to be going to give you 1600. Over here is going to give you 40, so that's 400, and over here is going to give you 3200 again. Alright, if quantity equal to 100, that is going to be 6000 minus 5000, so that is going to give you 1000. Over here 100 divided by 2 is 50, so that is going to be 1000. So that's going to be 100. Okay, 10 square is 100, and over here that is going to be equal to 2000 again. Okay, and if quantity equal to 120, then the profit for firm A is going to be equal to 0. For firm B is going to be equal to 0, and for firm C, and for the monopoly is going to be equal to 0. Okay. Alright, sorry, over here, if quantity QA equal to 0, profit for firm B should be 3600 because it's 60 square. Okay. Alright, so part C asking you, does your table from part B confirm the result from the text that firm A is going to produce QA equal to 60 in the Stack-a-Bird game? So as you can see from here, if in the Stack-a-Bird game where the two firms are competing with each other, firm A is going to earn a profit pi A and firm B is going to earn a profit pi B. Okay, and as you can see from the table, firm A is going to earn a highest profit if firm A is producing 60 units of output. Okay, so therefore the table basically confirms the result that okay, so I'll say the table confirms okay, the Slack-Hubbard equilibrium result that firm A should reduce QA equal to 60 in order to maximize firm A's profit. Okay. And in this case, the maximum profit is 1800, which is 1800. Okay, so as you can see from the table, the profit is maximized at a quantity equal to 60, and the maximum profit for firm A is 1800, and that's the maximum profit that firm A can make. All right. Now, how much would firm A have to produce to deter firm B's entry if firm B has a fixed cost of entry equal to a bit more than 400? Okay, so if fixed cost for firm B is just a little bit more than 400. Okay, so now looking at the table, you can see from here, firm B is going to make a profit of 400 if firm A is producing 80 units of output. And if firm A is doing so, then when firm B had a fixed cost of a little bit over 400, firm B will not be happy to enter the market because firm B can only earn 400. Okay, now if firm A producing 60 units of output, firm B is going to earn 900, and that is going to be above the fixed cost, and firm B is going to be happy to enter the market. Okay, and then they will have to share the market, and firm A is not going to become a monopoly. So so over here, as you can see, if firm B's cost of entry is a little bit more than 400, then firm A can produce a maximum of 80 units of output in order to deter firm B's entry. Okay, then I'll say from the table, okay, firm A will have to produce at least QA equal to AT, okay, in order to deter firm B's entry. Okay. Alright, because by producing at least 80 units of output, okay, then firm A can basically create a profit of 400 or below for firm B. Okay, so by producing 80 units of output, firm B now will be able to get a profit of 100 or lower. Okay, so I say at least basically means firm A can choose to produce more than 80, and the more firm A producing, the lower the profit firm B is going to get. Okay, so therefore at least firm A will have to produce 80, because if firm A producing less than 80, firm B will start making more profit than the cost of entry, and firm B is going to enter the market. Okay, so therefore because producing at least 80 units by firm A, then firm B's profit is going to be 400 below. Okay, and which is less than firm B's entry cost. Okay, and therefore firm B will decide not to enter the market. Alright, now if question asking you if the entry cost is just a little bit over 100, how much would firm A have to produce to deter firm B's entry? Okay, so if fixed cost for firm B is just going to be a little bit over 100, as you can see from the table again. Now over here, if firm B's fixed cost is just a little bit over 100, then firm A will have to produce at least 100 units of output in order to deter firm B's entry. Okay, because if firm A is producing at least 100 units of output, then firm B's maximum profit is going to be 100 or below that. So therefore, firm B's profit is going to be below the firm B's entry cost, and therefore firm B is not going to enter the market. Alright, so again from the table, firm A will have to produce at least 100 units of output. Okay, alright, in order to deter firm B's entry, because alright, if firm A produces at least 100 units, then firm B's profit is going to be smaller or maximum equal to 100, okay, which is smaller than firm B's entry cost, okay, and therefore firm B is not going to enter the market. Now, question asking you, would firm A want to do this? Okay, would it be worthwhile for firm A to deter firm B's entry in these cases? So now, as you can see, in order to deter firm B's entry under the case of fixed cost being 400 for firm B, firm A will have to produce 80 units of output, and therefore now if firm A is doing that, firm A will become a monopoly, and firm A will therefore get 3,200 in the market. Okay, so by producing more, firm A will be able to deter firm B's entry and become a monopoly in the market, and therefore firm A will earn 3,200, which is a lot higher than the maximum profit that firm A could have earned if firm A is competing with firm B under the stack converge game. Okay, so therefore firm A is going to be willing to do this. Okay, so I'll say now under the fixed cost, so if the fixed cost for firm B is just a little bit over 400, firm A firm A by producing 80 units of output will be able to deter firm B's entry. Okay, by producing 80 units will deter firm B's entry. Okay, and by doing that, firm A will become a monopoly. And therefore will earn a monopoly profit in this case. Okay, so when firm A producing 80 units of output, firm A is going to get a monopoly profit of 3,200, and this is basically bigger than a profit. Okay, so say which is Flasher. Okay, then the profit that firm A can get, okay, the maximum profit that firm A can get, which is equal to 1,800 under the stack average. Okay, so if firm A decide not to deter firm B's entry, they're going to be competing in the market under the Sackler-Bash equilibrium, and firm A, the maximum profit firm A can get is going to be 1,800 by producing 60 units of output. Okay, now by producing a little bit more, firm A will be successfully deter firm B's entry, become a monopoly, and get a higher profit. So therefore, firm A is going to do this. Okay, so therefore, firm A is going to deter firm B's entry. So it is worthwhile for firm A to do so. Okay. Now, how about if the fixed cost for firm A, the fixed cost for firm B is just going to be a little bit over 100. Again, by looking at the table, we are saying that firm A will have to produce at least 100 units of output in order to deter firm A, in order to deter firm B's entry. Okay, and in this case, firm A will become a monopoly, and firm A will earn $2,000. Okay. Now, again, compared to the profit, the maximum profit that firm A could have earned if firm A was going to compete with firm B in a Sackler-Bash equilibrium, the profit of monopoly under this case is still higher than the maximum profit that firm A can get under the Sackler-Bash. So therefore, again, it is worthwhile for firm A to do so. Okay, for firm A to deter firm B's entry by producing 100 units of output. Okay, so again, I'll say firm A by producing 100 units of output, okay, will deter firm B's entry okay, become a monopoly and earn a monopoly profit in under this case of producing 100 units of output, which is 2,000. Okay, and this profit is basically bigger than the profit that firm A can get. Okay, pi A under the Sackler-Bash equilibrium, which is 1,800. Okay, so therefore, it is worthwhile for firm A okay, to produce 100 units of output to deter firm B's entry. Okay,